Today, I'm going to talk about unsupervised learning, K-means clustering. In this project, we're using a dataset from the Kaggle website. Here, we're not predicting a target variable like in a regression or classification. Instead, we only have input features x, and the goal is to automatically discover hidden patterns or groups inside the data. Basically, we are clustering customers based on similarities in their behavior, such as income, spending habits, or age. Customers with similar characteristics will be grouped together in the same cluster. In K-means, the first step is choosing the number of clusters, which we call K. This means deciding how many groups we want the algorithm to separate the data into. First, we import the libraries. Basically, everything we need for data analyzing and clustering. So now we load the dataset, and here head helps us quickly see what the data looks like. And info gives us the structure, like how many rows, columns, and what type of data we have. This step just about understanding the dataset. Here we selected two features, which we realize the important features compared to others, annual income and spending score. We convert them into a NumPy array because k-means only works with numerical metrics. We are telling the model only look at these two behaviors and group similar customers together. Now we wanna find the optimal number of clusters using elbow method. Here we use a for loop with I in range 1 to 11, which means we test cluster numbers from 1 up to 10. Then I select k-means from Scikit-learn, and for each loop the value of clusters becomes I. In every iteration, the model is trained with a different number of clusters. I also use k-means plus, which is an improved initialization method for k-means. It helps choosing better starting centroids. The model usually uh, coverage faster gives more stable results. Next, I fit the model on the whole dataset X. Here, it's important to note that in unsupervised learning, we don't have a target variable, there is no train test split in this example. Then append the WCSS. Then we choose the table X and the Y and its size, color, and style for better visualization. From the plot, we can look for the elbow point where the improvement starts slowing down. In this case, we can choose K5 as the optimal number of clusters. Now I want to run k-means again, but this time with the final choice of 5 clusters. I again use the k-means plus strategy, and I set max iter in 300, which means the algorithm can update the centroids for a maximum of 300 iterations until um, convergence. Um, K-means also has random state, and I set it to 0. This is important for reproducibility. If uh, you also choose this number, we will have the same random state. Then I use fit predict. This method does two job together. Fit for train the model and finds the centroids, and predict assigns each data point to a cluster label. So the output is not prediction like regression. It's simply a label or tag slowing which cluster each customer belongs to. So, for example, if the first data point pits label 3, it means that customer belongs to cluster number 4. Since we select 5 clusters, the uh, labels go from 0 to 4. Now we visualize the clusters. Each color represents a group of similar customers according to their similarity, and the yellow point are the centroids, which are basically the center of each group. So, for example, one group is high income but low spending, another is low income but high spending, and we can say we have the 5 different groups. So now we can actually see customer behavior patterns visually. Now we expand the idea to 3 features: age, annual income, and spending score. So we add the age, and now instead of 2D, we move into 3D space. Uh, so this helps us get a more realistic customer segmentation. Again, we apply the elbow method, but now using 3 features instead of 2. The idea is still the same, to find the best number of clusters. We again choose 5 clusters and assign each customer into a group. So now clustering happens in a 3D feature space. Now I'm visualizing the result using a 3D scatter plot with Plotly. And here we use Go, which is just a Plotly graph. It's from the Plotly library for interactive visualization. So this is where things become more visual and intuitive. Now we are working with 3 features together. Income and spending were already there, as we can see, and now we uh, added age as a third dimension. So each point here represents a customer in a 3D space, and we can clearly see how customers are grouped together. Now it's much more powerful because we can actually rotate and explore the data visually. So everything becomes very clear, and you can see how each customer belongs to a specific cluster. One important thing to note, the k-means can work with more than three features, but the limitation is that we cannot visualize into anymore after three dimensions, and it's impossible for us. So beyond three features, the algorithm still works, but we lose direct visual understanding. So thank you for watching this video.